So in section 8.1, we're going to discuss linear equations and linear inequalities. Now this course in particular is going to work with equations quite a lot. We're going to solve quadratic equations, linear equations, rational equations, radical equations, exponential equations, logarithmic equations, equations. So it starts here with linear equations. Linear equations gets its name from the fact that when you graph either side of this, you're just going to get a graph that looks like a straight line. Oops, minus 6 equals 3y. When we solve an equation, you're going to try and isolate the variable. You're going to get that variable by itself. And in particular with problem number 20, the work on that's going to start by distributing the 3 here to both terms. So that would leave me with 6y minus 12 minus 6 equals 3y. From there, what I would do is combine like terms. So when you combine the like terms, that's these two right here. I get 6y minus 18 equals 3y. And now before we rush to move things one side or the other, let me explain a little trick that we're going to follow throughout this section. That is, when you're solving for an equation like this and you need to move the variable to one side or the other, choose the side with the largest coefficient. So 6 is bigger than 3, so I'm going to move everything to the left. Now in this particular problem, it doesn't make a big difference, but later on it does make a nice little bit of a difference that'll help us out and help us avoid mistakes. So let me subtract 3y from both sides. So that leaves me with 3y minus 18 equals what? 0. So I got my variable on one side. Let's put the constant on the other. So I'll add 18 to both sides. What does y equal? 6, right? Divide both sides by 3. Y equals 6. So, nice. If I was really anxious about this course, I'm like, you know what? I really got to pass this. How can I prove that I got that one right? Yeah, plug it back in and see if it works. 2 times 6 is 12, minus 4 is 8. 3 times 8 is 24. 24 minus 6 is 18. If I put it in on the other side, 3 times 6 is also 18. So, cool. At least I got the first one right. As I go through these, if there's something that I blow through a little too fast and isn't quite clear, let me know. Just raise a hand, ask a question. But please, don't just sit there and go, I don't get it. Because I want you to get it. Let's try problem number 22. 5 times 5 minus a equals 4a plus 37 minus 6a. Where do you think we should start on this one? Lexi? Yeah, distribute. Well done. So we get 25 minus 5a equals, and Lexi noticed that on the right-hand side there's like terms here and here. So I can combine those terms, and I get what? Thank you. Negative 2a plus 37. Now let's think about that little trick that I suggested in problem number 20. That is, let's move the variable to the side with the largest coefficient. So does that mean I'm going to move everything to the right side or to the left side? Where are we going to put things? On the right side. Negative 2 is bigger than negative 5. Now, it doesn't make a huge difference in this problem, but it does make a nice difference overall in some of our inequalities. So when I add 5a to both sides, I end up with a positive 3a plus 37. And it's nice to have a positive number here because people make less mistakes with positive numbers than they do with negative numbers. My variable's on one side. Let's put the constant on the other side. So I'll subtract 37 from both sides. I get negative 12 equals 3a. What does a equal? Negative 4. Good. Just divide both sides by 3, and we get a is negative 4. So, good. And like the previous one, you could go back up here and check it. That's fine. It would work. Now, what if I did things the other way? What if I looked at this and said, you know what? I want to put things on the other side. I had an instructor in college or in high school who always said, you know what? Let's put things on the left-hand side. So what if we did that? What if I added 2a to both sides here? Well, we could. Then I would get something like this. 25 minus 3a equals 37. Subtract 25 from both sides. And then if you carefully divide by negative 3, you're okay. It's just the problem is that, like I said, people make mistakes with negative numbers. And in particular, when we start working with inequalities, this could cause a problem. Because you're going to have to do a little extra work dividing both sides by a negative. Anything on problem 22 here? Let's try problem number 26. X over 2 plus x over 3 equals 10. Most of you would not be happy to solve a problem like this on an exam. Why not? What's wrong with this problem, or at least what's unpalatable about this problem? Nothing? Yeah, please. It's close. That's what we're eventually going to do. But what you're getting at is what I was kind of asking, and that is, this one's got fractions. Most of you, in my experience, don't really like fractions. They're a pain. So let's see if we can't work our way around them. Our fix for this is we're going to multiply both sides of the equation by the lowest common denominator. So what's the LCD for this equation? 6. So in multiplying both sides by the LCD, it's going to look like this. I'm going to multiply the right-hand side by 6, and I'm going to multiply the left-hand side by 6. Now when I multiply the left-hand side by 6, really I have to distribute that term. So here's what I'll do. Let's just do it right here. Everything's going to get multiplied by 6. Now why am I multiplying by 6? It's the least common denominator. And what do you think I want to happen when I multiply by 6? Canceled. Yeah, exactly. Thank you, ladies. I want to get rid of the fractions. I want to cancel them. So to help that, on the left-hand side, I'll write that as 6 over 1, because I want to encourage you to do this cancellation. Do I need to write this as 6 over 1 on the right-hand side? No, because there's no cancellation here, right? It's just 6 times 10 is 60. But on the left-hand side, I get some cancellation. 2 goes into 6 3 times. So I end up with 3x plus what? 3 goes into 6 2 times. So it's 3x plus 2x. Or in other words, 5x equals 60. Somebody impress me without your calculator. 12. Thank you. X equals 12. Not bad. So the trick in working with fractions is really not to work with them. It's to multiply through by a lowest common denominator and get rid of them. And that's exactly what we did here. We're going to try another one. similar to that, a little bit more involved, and let's see. That's going to be problem number 30. So 2/3 times x minus 3 equals 1/6 times 7x plus 29 plus 3. Whoops. There we go. What's the lowest common denominator in this case? 6. So just like the last problem, we're going to multiply through by the common denominator and clean some things up. We should get a lot of things to clean up here. And let's see. We'll have 2/3 times x minus 3, 1/6 times 7x plus 29, plus 3. So everything's going to get multiplied by 6. So this is going to get multiplied by 6. This is going to get multiplied by 6. And this is going to get multiplied by 6. Everything gets multiplied by 6. So 6 here, 6 here, and 6 here. Now where there's fractions, instead of just a 6, I'm going to write it as 6/1. I want to encourage you to do the cancellation on these things. So the tricky part is right here when you're facing stuff like this. And the reason it's tricky is because people want to multiply here and then multiply here. And you can't do that. We're all going to multiply these two together, and that's going to be it. I'll go back after the problem and show you why. But these are the ones that multiply and cancel. So what's going to happen here? 3 goes into 3 once, and into 6 how many times? 2. So Alex, what's out in front of my binomial now? What am I left with there? Alex? What's left in front of my binomial? I canceled. 3 goes into 6 twice, so I've got 2 here and 2 here. So 2 times 2 would be 4. Now over here on the right hand side, let's continue there. This one's a little easier, right? That cancels, and that's where we're left with just a 1, which you don't necessarily have to write the 1. You can skip that if you'd like. Plus, is there any cancellation in on this one? No, it's just 18. Let's distribute here. 4x minus 12 equals 7x plus 29 plus 18. And sorry about my little chicken scratch there. We can combine like terms. On the right hand side, when we combine like terms, we get a 47. So 4x minus 12 equals 7x plus 47. And I have a feeling this one's not going to work out even, but that's okay. Terry, according to Jeff's rule, what side of the variable, or what side of the equation should put the variable on? The left-hand side or the right-hand side? Right-hand side, good, because 7 is bigger than 4. So I'll subtract 4x from both sides. That's going to put the variable on the right-hand side. So negative 12 equals 3x plus 47. If I subtract 47 from both sides, so minus 47, kind of running out of room here, that's okay. Negative 59 equals 3x. What's the last step? Thank you, divide by 3. So negative 59 divided by 3. Thanks, Dwayne. So, didn't work out even, but that's okay. That's our answer, and that works fine. How are we looking on number 30? These need practice. Don't kid yourself about them. Make sure you do practice some because we're spending a lot of time on it in class. We're going to spend some more time on it as we go through this. And it's just something I want you to know is to work with fractions and decimals. All it is really is an extra step. You want to just clear them out. I don't really work with them myself. I just get rid of them as fast as I can. So over the last couple years, I've been teaching statistics using Google Sheets for part of the course. And the cool thing about that is you can program in your own formulas. Now that means working with formulas and in some cases solving for a specific variable. And that's what we're going to practice right here, is solve for a specified variable. Now that might sound kind of vague at this point, but let me make it a little bit more concrete. Problem 40 gives you this equation. P equals 2L plus 2W. If you're curious, that's really the formula for the perimeter of a rectangle. Perimeter would be the length around. You've got 2 lengths plus 2 widths. Gives you the perimeter. But in this particular formula, they want you to solve for for L. So they're going to put a little L here and ask you to solve for L. Lexi? It's a good question. No. What's different about this one is that our answer is not going to be a number. It's going to be an expression. Yeah, you're thinking of like slope and intercept and finding x and y intercepts. Yeah, at that point you'd plug in x equals 0 or y equals 0. Yeah. So, but it's a good thought. What we're going to do instead, since we want to get L by itself, the easy thing to do first is to move the 2W to the other side. And I can do that by subtracting. So minus 2W on both sides. So Zach, what equation would that give me if I subtracted 2W from both sides? Perfect. P minus 2W equals 2L. Now we're almost there. We've got 2L. We want L. So let's take a look at the 2L term. What's the 2 doing to the L? It's multiplying by it. So Janae, what's the opposite of multiplication? Divide. And so what we're going to do is divide both sides by 2. We're going to undo this operation. And when we do that, we get P minus 2W over 2 equals L. And that's what we're looking for. We're looking to solve for L. Generally speaking, you kind of work these in the reverse order of your order of operations. If you remember PEMDAS, please excuse my dear Aunt Sally, you do multiplication and division, addition and subtraction. When you're solving these types of problems, you do addition or subtraction first, and then multiplication and division next, in general. Although, having said that, let me immediately make an exception. Here's another geometric formula. In case you don't recognize it, it's the area of a triangle. We want to solve for H. I would strongly suggest we use an idea that we've already discussed a couple times here today. That is, let's start by clearing out the fractions. So Sydney, what can I do to get rid of the fraction in this particular case? Perfect, thank you. Multiply both sides by 2. And on the right hand side, I'll just think of it as 2 over 1, just out of convenience, because I want you to do that cancellation. Adriana, when I multiply it by 2, what equation is going to pop out? Perfect. So the 2 and the 1/2 cancel each other out. You're left with 2a equals b times h. Last step, Shannon, would be to do what? Divide by, we're trying to solve for h. So h is being multiplied by b. The opposite would be to divide by b. Good. So divide both sides by b. And you can see that on the right-hand side, the b's cancel each other out. So you're left with the expression for h. 2a over b equals h. Let's try one more like that. Before I do, anything on problem 42 that's not quite clear? All right, appreciate the help on that one. Problem number 48. This one comes from physics. If I were to invent a little story problem about it, be a ball is thrown upward from ground level at a speed of 48 units per second under the influence of gravity. In any case, we don't need to know the physics. We just need to know how to solve for a. So this is not times a, it's just telling you what variable we're solving for. So put parentheses like that maybe. Somebody impress me. How would you start? What have we been doing quite a lot of so far today? All right, we want to get a by itself, but a good place to start to make this problem more friendly to you. Get rid of the fraction. Good. So let's start by getting rid of the fraction. Courtney, suggestions as to how to get rid of the fraction in this one? Perfect. Multiply everything by 2. 2 is going to be our lowest common denominator. So if I multiply everything by 2, it should be in good shape. So let's do that. All these terms in blue, everything separated by an equal sign, subtraction sign, or an addition sign, all of them are going to get multiplied by 2. 2, 2, 2 over 1. Why am I multiplying this one by 2 over 1? Yeah, to help remind us to get rid of the fraction there. When I do that, that's going to cancel. And I'll end up with 2h equals 96t plus at squared. Looking better. At least we don't have any ugly fractions around. Christian. Now what? We'll eventually solve for a right there. Will be an easy next step. Perfect. Subtract 96t from both sides is exactly the answer I was hoping for. At squared. That's looking a lot closer to home. Muhammad. Now what? What's the last step to solve for a? Yeah, perfect. Divide both sides by t squared. So you're left with a equals 2h minus 96t over t squared. One thing to understand about this answer here, and that is those terms are kind of joined together mathematically because of the subtraction between them. you can't cancel into this subtraction. That is, I can't cancel out that t no matter how tempting it looks. These terms are married. If you break up a marriage, I'm going to write homewrecker all over your exam. It's bad news. You don't want to be a homewrecker. So if you're just dying, chomping at the bit to do something, what you could do is write this. You could write 2h over t squared minus 96 t over t squared. Now there's no longer a subtraction or addition marrying these two terms, so you can cancel into this. You can do t and the t squared cancels, leaving you with 2h over t squared minus 96 over t. So as a final answer, if you want to write this, I'd be happy here. If you want to write this, I'd be happy with that one too. What I'm asking you not to do is cancel the t into the t squared. That'd be bad. All right, so that's a few examples of solving for a specified variable. And I'm also, in my own indirect way, telling you, a type of problem to be ready for your exam. Anything else on that one? Let's work with inequalities. And I'll begin with problem number 56. 5 times 3z plus z is greater than negative 3 times z plus 3. All right, so we've got an inequality as opposed to an equation. A lot of our work is going to be similar. We'll start by distributing in both terms, both sides. So I get 15 plus 5z is greater than negative 3z minus 9. Cool. If we were to apply Jeff's rule, what side should I put things on? The left-hand side or the right-hand side?
Left side.
Yeah. 5 is bigger than negative 3, so perfect. I'll add 3z to both sides, and I end up with 15 plus 8z is greater than negative 9. So my variable's on one side. I want to put the constant on the other side. So I'll subtract 15 from both sides. 8z is greater than negative 24. So z is greater than negative 3. Nice. But what if you forgot my little rule here that says, let's move things to the side with the largest coefficient? What difference would that make? Let's find out. Let's take this and resolve it starting here and see what difference that would make. So I'll go back to 15 plus 5z is greater than negative 3z minus 9. And instead of moving the 3z over here, let's move the 5z to the right-hand side. So I'll subtract 5z. And I get 15 is greater than negative 8z minus 9. If I add 9 to both sides, I end up with 24 is greater than negative 8z. And if I'm not too careful and just divide by negative 8, I get negative 3 is greater than z. And that doesn't look right. Because here z is smaller than negative 3, and here z is bigger than negative 3. How come I'm not getting the same answer in both cases? Adriana, it seems like you're chomping on the bit. You want to tell me the answer? Go ahead. Exactly. When you divide or multiply both sides of an inequality by a negative number, you have to flip the direction of the inequality. So right here, I had to divide both sides by negative 8. That means I need to flip the direction of the inequality. And now that I do that, these two answers, the one in orange and the one in blue, are the same. You've got -3 is smaller than z, or z is bigger than -3. So they're saying the same thing. But the moral of the story here is that you've got to remember to flip the direction of the inequality. The reason we didn't have to do that in the first one is because we chose to use Jeff's rule. We move things to the side with the larger coefficient. So, can you get the right answer this way? Sure. But, it's just giving you less opportunity for mistake if you move things to the side with the largest coefficient. Not a big thing. It's a little trick to help you out, but you don't have to necessarily use it. The one thing you want to keep in mind, like I said, is that when you divide or multiply both sides of an inequality by a negative number, you must reverse the inequality. So that's the news of the day there. Any other comments on problem 56 here? Can you go take a picture of it? Yeah, go ahead. So we're going to move on to problem number 66. All set? Okay. So 66 gives you a plus 4 minus 10a is greater than a minus 16. Now, one thing that you're going to find as you watch some of my videos is that the software that I have to record these doesn't have a pause button. So I have a low-tech solution to a high-tech problem. Pause. All right. So what I'm going to do is I'm going to walk around and let you solve this one. Hopefully you'll go through this one faster than the Clemson offense can go through the Alabama defense and solve this and impress me. But if you have some questions as I go around, let me know. And if you're watching the video, just fast forward until the pause button disappears. So what was yes. Okay. All right, I'm happy to report to my YouTube subscribers that everybody got it right, which is good. All right, let's take a look here. Start out on the left-hand side by combining like terms. 1 minus 10 is negative 9, so it's negative 9a plus 4 is greater than a minus 16. Personally, the way I would work this is because 1 is bigger than negative 9, I'll move the negative 9a to the right-hand side. So let's add 9a to both sides. That gives me 4 is greater than 10a minus 16. So I got my variable on one side. Let's put the constant on the other side. So that means adding 16 to both sides. So let's do that. Plus 16. Whoops. So 20 is greater than 10a. What's the last step? Divide by 10. So divide by 10, and I get 2 is greater than a. You could also write that as a is less than 2. Either one is fine. Somehow or another, I prefer looking at the one on the right here, but both of these say the same thing. I was mentioning to Lexi that the alligator eats the bigger number, right? So 2 is bigger than a, or 2 is bigger than a. Either way, 2 is on the bigger side of that inequality. So a few more here. Anything on problem 66 before we move on to problem number 98? You guys have enjoyed fractions so much that I thought I'd throw some decimals at you, just to round out the fun. So problem number 98, 0.005 plus 0.8x is less than or equal to 0.5x minus 0.7. Well, what would you suggest we do on this one? I mean, decimals are only slightly less offensive than fractions, so most of you probably won't like working with decimals too much. So what could I do to get rid of the decimals here? Any suggestions? Come on, make me look good, right? Yeah, please. We could turn it into a fraction. For instance, 0.05 is 1 over 20. This is 4 over 5, etc. But it feels like more work than I want to do. I'm all about trying to do as little work as possible, at least in some senses. So what else could I do? Mohammed? That's kind of getting at the right thing. And what would move them over 2 spots? Multiply by a 1 followed by 2 zeros. So multiply everything by 100. And that'll move things over 2 spots. The equation that we end up with then would be what? Well, I guess it depends on the problem. In this particular case, the smallest decimal that I had 2 places, 0.05. So I need to move this decimal 2 places to the right. That's why I multiply by 100. If I had a similar problem, if, say, for instance, if this was 0.5, then really all I need to do is move the decimal 1 place to the right. So instead of multiplying by 100, I could multiply by what? 10, yeah. So a 1 followed by however many zeros it takes to move the decimal that many places. Yeah, so great question. Appreciate that. What do I get out of this one? 5 plus 80x. I'm glad you gave me 80x, not 8x. Is less than or equal to... Anyone? Well done. 50x minus 70. So again, get the variable on one side, the constants on the other side. Let's see. Christian, what side should we put the variables on? Which coefficient is bigger, the left one or the right one? All right, good. So let's move things to the left. So minus 50x on both sides. 5 plus 30x is less than or equal to negative 70. So my variables here, let's get rid of the constants, put them on the other side. Now when I divide both sides by 30, do I have to flip the direction of the inequality? Should I make that a greater than or equal to? No, because you're dividing by positive 30, not by a negative number. So that reduces to negative 5 halves, and I would accept negative 2.5. I would like it in lowest terms regardless. Yeah, either of these last two would be fine. So either of those two. All right, winding down this section, we got like about 4 more problems to go. Let's continue with problem number 94. (3a plus 1 over 3). So going back to the fractions, minus 4 minus 3a over 5 is less than or equal to negative 1 over 15. So another one with fractions, and I'm hoping that you're getting used to fractions. How would we start out? LCD? Good. So, Max, in this particular problem, what's the LCD? It's a number that all of these can multiply into evenly. So, yeah, 15. So the LCD would be 15. We're going to multiply each of these by 15. So that by 15. This one by 15. And this one by 15. You have to multiply both sides by 15. It is kind of included. That's a good question. I'm just multiplying the term by this, not the symbol in between. I could distribute a negative 15. I'll distribute the negative after I do my cancellation, though. That's when I want to handle the negative. It's a good question. You could do it now. It's not the way I generally do it, but you could. There's nothing wrong with it. Let's see. There's some cancellation here. 3 goes into 3 once. 3 goes into 15 5 times. So that leaves me with 5 times 3a plus 1 minus. So here's how I deal with the minus, Lexi, is that I just leave it there, and I'll do my cancellation. So when I do my cancellation, 5 goes into 5 once, and into 15 3 times. So you're left with 3 times 4 minus 3a. How about the right-hand side? Dwayne, what am I left with on the right-hand side? Good. Negative 1, just the numerator there. Thank you, sir. So negative 1. If I distribute here, what would I get? Zach?
15a plus 5
Mm-hmm.
minus 12 plus 9a.
Perfect. And on the left-hand side, we've got like terms. So thank you, Zach. 15a and 9a can combine, as can the 5 and the negative 12. Those are also like terms. So we end up with 24a minus 7 is less than or equal to negative 1. If I add 7 to both sides, I end up with 24a is less than or equal to 6. And here's where a lot of people get in too much of a hurry and make a mistake. What's a equal to? I mean, you guys are thinking now. Yeah. 1/4, excellent. A lot of people want to say, oh, a is, less than or equal to 4, which looks like it should be true. I mean, you got the 24, you got the 6. I mean, it's perfect, right? But if you're being careful here at the end, 24a divided by 24 is less than or equal to 6 divided by 24. You end up with a is less than or equal to 1/4. So, need to be a little bit careful at the end there. Say again? Oh, the minus 7 comes from combining the like terms here. 5 minus 12 is negative 7. And the 24, likewise, comes from these two terms. Just combining the like terms there. It's all right. I appreciate the questions. Definitely help out. Okay. Let's see, 2 more? 3 more. 3 more. What's that? Got it? I'm going to try and hurry these things up because this video is getting pretty long and I know you guys need a little bit of a break of some sort. So let's look at problem number 88 together. 0.03x plus 0.05 times 6,000 minus x equals 280. So some more decimals, but really it's just one extra step. It takes one extra step to get rid of the decimals, and then you got a friendly linear equation. So Darren, what can I multiply everything by to help clear everything out? Clear out all the decimals. 1,000 would work, but it's kind of like squirrel hunting with a bazooka. It's overkill. All right, I don't need to go up to 1,000. Is there something smaller I can use? 100, yeah. Because all we need to do is move the decimal 2 places to the right. So that's the most I want to do. Just move it 2 places to the right. So I'm going to multiply everything by 100. And let's start on the right. So without taking out my calculator, 28 times 1 is 28, and then I'll have 1, 2, 3 zeros. So they give me 28,000. Over on the left, moving that 2 places to the right, Kelly, what would that give me? 1, 2, 3x. And then how about in front of this parenthesis here? Just 5, right? So 5 times 6,000 minus x. Notice what Kelly did not do. She did not multiply this inside the parentheses. She didn't get 600,000 minus 100x. You just multiply it here. Let's finish this up. Thanks for the help. 5 times 6 is 30. How many zeros should follow that 30? 3. 1, 2, 3. So 30,000 minus 5x equals 28,000. Combine the like terms. That's here and here. Janae, when I combine like terms on the left-hand side, what would they give me, please? All right, minus 2x. Thank you. So I get the variable on the left-hand side. Now what? Nick, any ideas? What should I do next? Perfect. Minus 30,000. So I get negative 2x equals negative 2,000. What does x equal? not all at once. All right, x is 1,000. You could actually check that by plugging it in your calculator and convince yourself that you got the right solution by just plugging it in. See that it works. And I'll show you a trick sometime later in the semester of how to check that on your graphing calculator fairly easily. But it's a trick that works on your graphing calculator. All right, two last ones, and I'm going to make them quick and easy. Let's do one of your homework problems. Is that okay? You know, you guys aren't going to get mad. You're going to go out and rate my professors like, guy was always doing my homework problems. I hated it. All right, so problem number 85. 5x plus 10 equals 5x. This is kind of a strange problem. In fact, if you looked at this carefully for a moment, you might think, something looks wrong. But let's not think about it too much. Suppose you said, all right, I know I need to get the variable on one side. Doesn't matter which side because they're both the same, so I'll subtract 5x from both sides. What equation do I get from that? What's the result? Yeah, 10 equals 0. Maybe I was asleep that day in high school when they taught us that. I don't remember the 10 equals 0. In fact, it doesn't. This is what's called a contradiction. There's no solution. Contradiction. No solution. You could also put null set here. Would be another way to address that. I do not typically test you on stuff like this. It's not a typical Jeff question, but you will see it pop up here and there in the homework, so at least you've been forewarned. Now on the flip side of things, problem number 80. 2 times 2a plus 1 minus 1 equals 4a plus 1. Let's work on that one. A natural thing to do would be to distribute. What makes sense to do after we distribute? Yeah, combine like terms. So, Shannon, when I combine like terms, what do I get, please? For a plus 1? Okay, good. Boy, the left-hand side and the right-hand side look kind of similar, don't they? What's that? It's all solutions. Yeah, all real numbers are solutions here. Now, you can go a little farther than this. If you subtracted 4a from both sides, what you see is 1 equals 1. That's always going to be true. Doesn't matter what the variable is, 1 equals 1, so all real numbers would be your solution. Cole?
So on the test, do you want us to simplify it to 1 equals 1? Or
I mean,
plus 1 equals 4 equals 1?
once you see it that, it's something like this that's always true, it can't miss. If you wanted to write all real numbers or negative infinity to infinity, or my personal favorite, and maybe a bonus point for you if you write the script R, that really means all real numbers. Any of these is fine. Well, congratulations and well done on sucking it up through a very long section. Let me give you some homework. This is section 8.1. So the homework is just the odd problems, 15 through 33, 39 through 65, 71 through 83, and 91 through 97. And again, that's just the odds. No, all of them. I mean, the whole set of this. So the odds applies to everything here. Yeah. So there's a couple reasons I assign just the odds. One of them is that we spend time doing the even problems, so you've already done some of the even problems. Second is that the odd problems are answered in the back of the book. But the most important one, I'm a nice guy. I'm saying, hey, you know what? Just do every other one. Just do the odds. So that's the most important reason. All right. Well done.